Let's keep exploring objects, and this lecture will bring us to object methods. So we learned that objects, just like arrays, can hold different types of data, and they can hold even arrays, and in fact, they could even hold objects inside objects. But now we can take it even further. And for that, remember how I said that functions are really just another type of value. And if a function is just a value, then that means that we can create a key-value pair in which the value is a function. And that then means that we can, in fact, add functions to objects. And so let's now see how. And once more, I will get back this object here, but we will change it up a little bit this time around. So here, let's simplify and just put the birth year. So just 1991. And I also want to add a Boolean here. As driver's license. Just to show you that we can hold all kinds of different data types in one object. But now let's also add a function here as a key value pair. So to do that, all we have to do is to add another key here. And the function that we want to add is again the calc_age function. So that's one of the favorites, as you can see, but it is because it's a very simple calculation that we can do with the birth year. So to do that, let's simply add the name basically of the function here as a key, so as a property. So calc_age, and then the colon. And now here we simply specify the function as an expression. And that works because the expression produces the value. And so we can just do this. So function, and just like before, we pass in the birth year, and we return 2037 minus the birth year that was passed in. So this is pretty similar to simply writing this, right? So a regular function expression. So const calc_age like this. This is how we used to do it before. And so you see that this is pretty similar. The difference is just in the syntax, because now calc_age is not a regular variable like here, but it's a property of the Jonas object. And so therefore we use the colon here, but the rest here is exactly the same. And so that's why it was very important that you understood what a function expression actually is. Because here we need the function expression to create this method. And that's what this function is called. So any function that is attached to an object is called a method. So of course we could have not used a function declaration here. So something like this. So function calc_age, for example, that would not work. We would certainly get an error here. So unexpected token function, because this is a declaration. And so it doesn't work here. Here we need an expression. And so this will work indeed. Okay, does this make sense? So if you can think of functions as simply being values, then you can see that a method is actually also a property. It just happens to be a property that holds a function value. So here we have a string value, here we have an array value, here we have a Boolean value, and here we have a function value. All right? So I hope that's logical. And now, just like we can access any other property, we can also access the calc_age property or method. So Jonas.calc_age. And so calc_age is now the function value. And just like any other function, in order to call it, we use the parentheses. And now we can pass in the year here. And so that should then calculate our age. And let's just log this result to the console here, just to see if everything works. And it does indeed. Okay. And you could also have accessed this method using the bracket notation. Because again, it's just as if it was a normal property. And the brackets would actually be necessary here. so that this then here is the function, and then we call the function using the parentheses. So let's try that. And yeah, here this needs to be a string. So like I showed you in the last lecture, and now here we get 46 as well. Okay, so just like I showed you in the last video with the operator precedence table, the first thing that happens here is that jonas.calcH is computed. And so this here will become the function value. And then with the parentheses, we call that function value here and pass in 1991. And the same thing here. So here we access the property calcH using the brackets, and then this here will basically be replaced with the function, and then we call the function right here, just like before. All right. Now, you might have noticed that the birth year 1991 that we passed here as an argument to the method is actually already defined in the Jonas object itself up here, right? So we already have this information in the Jonas object. And so writing the same number here and here is not ideal, because we might make a mistake and pass in the wrong year. For example, right here. So Jonas's birth year is 91, but here we could, for some reason, accidentally do 92, and then it would be wrong. And even if we do not make any mistake, this is still not ideal, because we are not keeping the code dry. So we're violating the don't repeat yourself principle. So if we know the birth year of Jonas, it should only be written in one place, not in multiple places. Because if that might change, then we have to change it everywhere. That's always the philosophy that we need to keep in mind. So what if we could actually access this birth year property directly from the Jonas object instead of having to pass it in? Well, it turns out that we actually can. And that's because in every method, JavaScript gives us access to a special variable called this. And so what we can do now is in this calcH function, we can read the birth year directly from this object itself without having to pass it in as a parameter here into this function. All right, so let me copy this and comment this one out, just so that we keep a record of what we did. But this here will be the new version. So now we no longer need this parameter, and we will read the birth year directly from the object. And for that, again, we will use the this keyword. So the this keyword, or the this variable, is basically equal to the object on which the method is called. Or in other words, it is equal to the object calling the method. So let's see who is calling the method. So down here is calcH, and the object that is calling the method is Jonas, because that's where the dot is. And let's forget about this one. I'll actually comment it out here. And so again, the object that is calling the calcH method here is Jonas. And so that means that inside this method, the this variable or the this keyword will point to Jonas. And so let me just write this.birthyear here, and then I can explain it even a little bit better. So here we don't need to pass the 1991 here, and I will run this now, and we still get the correct result. So great. And to make this even more clear here, let's also log this to the console. And indeed, this is the whole Jonas object. And so again, that's because the Jonas object is the one who is calling this method, so this function. See here, it's jonas.calcH. And so whatever appears before the dot is the one who is calling the method. And so therefore, in the method, this points to Jonas now. And if this points to Jonas, then this.birthyear is of course this value that we have right here. Great. So you see that the this keyword is something really, really useful. And we will learn even more about the this keyword in greater detail in a later section. For now, I just wanted to introduce you to this concept. And I know this can be a bit confusing, so really make sure to maybe pause the video and really analyze what's happening here. Maybe you can even rewind a little bit and hear my explanation again. That might be useful too. Now, you might argue that maybe we don't even need this confusing this keyword. Why not just do Jonas.birthyear here instead? Well, because that would actually still violate the don't repeat yourself principle. It would work just the same here now, but then let's say that we need to change the name of the object. So we change it here to Jonas2, and then we call Jonas2 down here. And then the code will no longer automatically work. Because now Jonas is not defined, of course. And so we would have to keep that in mind and then come here and manually change this as well. While if we had the this keyword, then everything will keep working without us having to change it there. Because now this will simply point to Jonas2, because that is the object calling the method. And so therefore, it's always a good idea to reference the object itself and not hardcode the name of the object. So let's put it back to Jonas. And yeah, much better. So this works great already, and we're really going into some more advanced territory here. So I hope you're still following me and you're still making sense of everything. However, we can actually even take this a little bit further. But don't worry, it's not going to get a lot more confusing. Just a small variation of this. Because let's say that we need to access the age multiple times throughout our program. So that would be like calling this a couple of times. So let's say in 3 places of our application, we need to access the age. And so, of course, this will work. And indeed it does. And it always locks the Jonas object because we still have this here. So this makes it a bit easier to view. And so what happens here is that the function will get called a total of 4 times. And so this computation here will be done 4 times. And in this case, that's not a big deal, but it might be like a heavier computation that actually takes some more time. And so it would be a bad practice to do this multiple times. Instead, what we can do is to just calculate the age once, then store it in the object, and then when we need it at a later point, we can then just retrieve the age as a property from the object. So I hope you're following me here. So I will again copy this and comment it out so that we keep all the 3 versions that we did here. So what I was trying to say is that we can now use the this keyword also to store a new property. So we can say this.age is equal to this here. So we calculate the age, and then we create a new property on the current object. So in this case, on the Jonas object. And remember that we can use the dot notation like this to create new properties. So we did that in the previous lecture as well. Where was that? Yeah, right here. So here we created Jonas.location and set it to Portugal. And so here we are essentially creating Jonas.age and setting it to this age that we just calculated. And then we can simply return this age. And of course, we don't even need to return anything if we didn't want to. We could make this method only calculate the age, but not even return it. But I think it's a good practice to actually also return it. And so now here we can replace the function call with simply a request for the age property. And notice this trick that I did here again with the command D, right? So this gives me multiple cursors, and then I can do one operation in multiple places at the same time. So that's a really handy shortcut. So again, command D or control D, and in the menu bar, that means add next occurrence. So let's test this, and the result should be the same. And it is. but we only needed to calculate the age once. Then from here, we simply retrieve the property that we had already calculated before. And so this is the most efficient solution, let's say. All right, and now I actually have another small challenge for you that you can do just in this video. So I want you to write a method called getSummary, and this method should return a string which should kind of summarize the data about Jonas, or of course any other person data that you might have used. For example, let me again, actually we can get rid of this. So let me write challenge here again, and then do an example string. So I want you to write, for example, this. Jonas is a 46-year-old teacher. And we now could actually add all the data here to the string, but that would be too much work. And I'm a bit lazy now. So let's just also say if I have a driver's license or not. So Jonas is a 40-year-old teacher, and he has a driver's license. And it says that I have a driver's license because has driver's license is true. But if it was false, then here it should say, and he has no driver's license. So it's either A or no. So figure out how you can do that. And so I hope you managed to do it. It's a bit similar to what we did in the previous lecture, but this time I want you to actually write a method on your own. So give this a try, and I see you here in a second. Okay, so let's add getSummary. And remember that you need to have a comma between the properties. And so that's true also with methods. So here we need a comma, and then just a function. And it will then get all this data, of course, from the current object. So actually, let's first call this method. So, and we're doing it inside a console.log because, of course, we want to be able to see the summary string as a message in the console. So jonas.getSummary. Okay, so which is the object calling the method? It is Jonas. And so therefore, the this keyword inside of getSummary will be Jonas. So I hope that this one is clear at this point. So let's now build a string here. And starting with the name, it is at this dot first name is a, and now the age. So this, and now what do we do here? Should we use the age property, or should we do calc age? Well, I would say that we should do calc age because we cannot assume that calc age was already called before. Okay, and if we don't call calc age before we call getSummary, then the age property would not exist. And so it's better to actually do calc age here. And so I think we did this before. So in a template string, we can easily do a function call. That's not a problem at all. So this.calcAge will call this other method, and this will then return the age. All right. And maybe it might be strange for you to call the function also on this, but well, the rule is just exactly the same. This is Jonas in this object. And so this is essentially the same as writing it here. All right. So this will become the age. And so year old, and now the job, Jonas.job. And he has, and now we need to decide between a and no. So let's do a ternary operator here. So we get this dot driver's license. And basically, if it's true, then we want the result of this operator to be A, and if not, we want it to be no. And then driver's license. Okay, makes sense? So again, here we want either A or no, depending on the state of the has driver's license property. So we get that property by calling this dot has driver's license. And here we're using the ternary operator. And so if this first part is true, then the result of the operator will be A. And otherwise, the result will be no. And so that's what will then be put into this place of the sentence. Okay. And we already called the method down here, and we logged it to the console. And so I think this should work now. And it does. So Jonas is a 46-year-old teacher, and he has a driver's license. Now just to test, let's set it to false. And he has no driver's license. Beautiful. Okay. And yeah, that's all the code that I had to show you in this video. And now just to finish the lecture, which I know is already running quite long, but I want to basically build a bridge between this method and the array method lecture. So remember that we used methods on arrays previously. So we can quickly go there. So it was before this challenge. Yes, indeed. So for example, here we have friends.push. And so we have an array, and on there we call a method. So just like we did in this video. Now what this means is that arrays are actually also objects. They're just a special kind of object. And so they have functions, or in other words, they have methods that we can use to manipulate them, like push, pop, shift and unshift, and many more. All right. So in this lecture, we created our own methods on our own objects. But here we basically used built-in methods on arrays. And so once again, that means that arrays are actually also objects. That's why they can have methods as well. And we will dive deeper into why things work like this, but I wanted you to realize this early on in the course. This is quite a complex topic, and so there is really a very exciting journey still ahead of you. So I hope you're enjoying this journey so far. And now to test your knowledge, there is coding challenge number 3 coming up next. And here goes your next coding challenge. This time number 3, for you to review all the material about objects. And I hope that you're really doing all these coding challenges, because as I mentioned earlier, they are really, really important for your progress. And I designed them all very carefully to exactly match the progress of the course and place them in strategic points of the curriculum. So I cannot stress enough how important it is that you do these challenges, even if it's a bit difficult, but that's why they are called challenges. They are really to challenge you and to make you think, and if necessary, spend half an hour or 1 hour even to really try to figure out how the code works. Without coding on your own, it's impossible to learn programming, believe me. But anyway, let's now get to the challenge. And in this one, we're going back to Mark and John comparing their body mass indexes. And this time, we're going to use objects to implement these calculations. So here we have the formula again to calculate the BMI. And so your tasks are, first, for each of them, so for Mark and John, create an object with properties for their full name, their mass, and their height. So their full names are actually Mark Miller and John Smith. Then create a method called calcBMI on each object, which will then calculate the BMI based on the data that is on the object. So create the both method and add the exact same method to both objects. So write this method first in one of the objects and then copy the exact same method without changing it to the other object. And this method should store the BMI value to a property, and it should also return it from the method. So a little bit like the calc_age method that we did in the previous lecture. Then log to the console who of the two has the higher BMI. And this string should look like this. So it should include the full name. And actually here it's not the full name, but do include the full name. That's why we have it. So John Smith BMI is higher than Mark Miller's. So not Killer's, but Mark Miller's. And then also include the actual BMI value here. And here is the test data, and I believe it's the same data as before. So good luck with this challenge. And again, it might be challenging, but please give it a try anyway. Okay, so I see you here in a minute, or maybe in half an hour, who knows. It doesn't matter how long you take. Okay, so let's get to work. So, number one is creating an object for each of them. So object Mark. So full name property Mark Miller. Then the mass, which is 78 kilograms, and then the height, which is 1.69 meters. So that's it for now. And now I'm just gonna copy this. As always, I'm a bit lazy, and that's just how programmers are, I guess. So John Smith, and he is 92 kilos and 195 meters tall. Okay, so that is point number one. And now we will create the calc_BMI method. And then a function without any parameters, because we will take the data directly from the object, just like we did it with the calc_age method previously. And remember that it says here that we should store the BMI value to a property and also return it from the method. So this means that we will do this dot BMI and then do the calculation here. And remember, from the formula, the BMI is calculated by this dot mass divided by this dot height squared. So exponentiation operator with 2. And then also return it. So this dot BMI. And just to see if this actually works, let's actually call this method. So mark.calc_BMI. And now I will quickly log to the console the property that we just created. So I could have logged this to the console directly, but I want to do it this way now, and it doesn't really matter. So with this, remember, we created a property called BMI. And so that is now, of course, accessible here. So mark.BMI, because remember that here in this method, this now points to Mark, because that is the object that is calling the method. And therefore, this .BMI will be on Mark. So mark.BMI equals mark.mass divided by mark.height. And so that's how we get this data into this method. All right, so that's essentially what we learned in the last lecture. And so here I'm doing the same. I'm first calculating this value, and then I'm doing mark.BMI, which was added here in this method call. Of course, without this method call, mark.BMI would not be available, because this method here doesn't call itself. We need to explicitly call it. Now console, missing the .log. How can that still happen after all these years? Okay, so here we get the BMI of 27, which seems about right. And now as I said, we will simply go ahead and copy this method exactly the same to this John object, and it will work just the same. Believe me. So let me show that to you. So now we call John.calcBMI. And so now the object calling calcBMI is John. And so now in this method here, this will point to the John object. And so this time, John.BMI will be calculated using John's data of mass and height. Okay? Are you still following that? As always, you can pause the video, analyze the code on your own, or you can always rewind to hear the explanation again. I actually like to do that myself when I watch other online video courses. So I think that's a good tip, maybe. Anyway, so we just calculated the BMI of John here as well. And so now I'm logging both to the console. And so, yeah, this one also looks correct. And so this means that simply copying this method from one place to the other actually makes it work and adapt to the data of each object. Now, having the exact same code in both of these objects kind of violates the don't repeat yourself principle, right? And actually, there is a way in which we can avoid this. And of course, we will learn how at a later point in the course using something called object-oriented programming. But for now, we are still learning the basics and just want to make things work. And of course, have some fun along the way. So this was the hardest part, I believe at least. Now all we have to do is to write this string here. Let me actually copy the example so we have it as a reference down here. Otherwise, I'm going to get a bit lost. So, if mark.bmi is larger than john.bmi, then console.log. So let's get the full name now from the object. So mark.fullname BMI. And now we also need it here in these parentheses. So let's put it there. Mark.BMI is higher than, and now let me just copy it here. So, and again, I'm using Command D to select the next occurrence, and then let's just replace it with John. So Mark's BMI is higher than John's BMI. And now let's grab this again. Else, if John BMI is larger than Mark.BMI, then essentially say the opposite. So here it's going to be John. And again, Command D. And here it's going to be Mark. Okay. So 27 is higher than 24, and that 27 belongs to Mark. And so this seems to be about right, but it's not completely right. So, of course, here it should be lowercase. So BMI, and now I cannot use the Command D because then it will select this one as well. So I'm double clicking on this one, and I hope that you're finding these VS Code tips useful as well. So I'm clicking, or actually I'm double clicking on this one. Then I hold down the Command key, which in your case might be the Control key or maybe the Option key. So I know there are different configurations for this, and it might not even work for you. So please don't ask any question in that case. But for me, I just have to hit Command, and then I can double click on multiple words, and then all of them get selected. So now I have these 4 multiple cursors here again, and I can simply delete all of them and write the one that I'm interested in. So that's the lowercase BMI. And now we get the correct values. And also this conditional logic is correct as well. And so with this, we did actually solve the challenge. And with this, we also finished this introduction to JavaScript objects. And once again, I really want to congratulate you for the progress that you're making here. Great job and really well done. And I really mean it because I know how hard it is to stick to a course like this and to learn a completely new thing that is probably a bit confusing for you at this point still. Just keep in mind that that is absolutely no problem at all. And actually, in the next section, I believe, I have a video about how to learn, basically. So about learning how to code. And there's a lot of great tips that I'm sharing there. So once you reach that, make sure to watch it carefully. But now, anyway, I will leave you to review this lecture if you want, or to move on together with me to the next video, where we're now going to start talking about loops. When we talked about the if-else statement, I mentioned that it's a control structure, and also that there are more control structures, right? Well, one of the other control structures are loop. And so loops are our final big topic in this JavaScript fundamentals section. So loops are a fundamental aspect of every programming language because they basically allow us to automate repetitive tasks. So tasks that we have to perform over and over again. And here I like to use the analogy of a gym. So when you go to a gym, you might, for example, lift weights, right? And let's say that you do 10 repetitions of a certain weightlifting exercise. So we could represent that by doing something like this. So lifting weights repetition 1. And then some more emojis here. Okay, so repetition 1. And remember, we want 10 repetitions. So we would have to paste this code here 10 times. And I don't know even if this are 10 times or not. But anyway, you can start to guess that this is probably not a best practice. Just imagine that we had 30 repetitions instead of just 10. And then if we wanted to, for example, change some word here in this string, then we would have to change that in all of them. So this really violates the don't repeat yourself principle, right? Because we're basically repeating the same code here 10 times, and all we're changing is just this number. So instead of doing all this, we can now create a loop and then put one of these lines of code in there, and the loop will then run that code over and over again until we tell it to stop. And so let's implement a so-called for loop now. And that's a loop which has a counter. So let's do that. And we simply write for and open parentheses. So a little bit like the if statement. And this is a for statement. And so it looks similar. Now the loop statement has 3 parts. The first part is the initial value of a counter. And in the case of this current example, the counter is the value that will start here at number 1 and go all the way to number 10. So let's call this counter rep, which stands for repetition. And so here we literally create a variable called rep. And we start it at 1 because, well, that's our first repetition. Okay? And here we need to use a let variable because this counter will later be updated by the for loop. So that's the first part of the for statement. Then we use semicolon and go to the second part. And the second part is a logical condition that is evaluated before each iteration of the loop. So before each time that the code in the loop is executed. So let me just write it here first, and then this will make more sense. So our condition will be rep needs to stay below or equal 10. So again, this condition that we just described here will be evaluated before each iteration of the loop. Now, if the condition is true, then the next loop iteration will run. But as soon as this condition is false, then the loop stops. And so no more code will then be executed. So basically, the loop will keep running while this condition stays true. And this is really important to realize, and let me actually write that down here for you. So for loop keeps running while condition is true. So this is the kind of notes that I hope that you are taking throughout the course, but this one is really important, and so I wanted to write it down. Okay, and so now I hope it makes sense that we have this condition, because in each iteration of the loop, the rep counter will get increased. And so at a certain point, it will reach 10, and with 10, this condition is still true. So 10 is still less or equal than 10. But then after that, it will be 11. And so then repetition is no longer less or equal 11, and then the loop will stop. And at that point, we will have printed these 10 strings, basically. So let's continue writing this so that in the end, we actually make that work. So speaking of increasing the counter, that is actually the third part of the for statement. So another semicolon here. And now here we actually update the counter after each iteration. So that's necessary because right now the counter would just stay at 1 forever. And so this condition here would never be false. And so what we do here is to now increase the counter by 1 after each iteration. So we can say rep equal rep plus 1. But does this look familiar to you? So basically increasing the value by just 1. Remember that in the last section, we actually learned about a special operator which does just this, but in a much simpler way. So instead of writing rep equal rep plus 1, we can simply write rep plus plus. And so this will take the rep value and increase it by 1. All right. And now all we have to do is to write the code that we want to be repeated. And so let's copy this string here. Okay. And let's say 1, and then it will print this string 10 times. So let's start with that. And then afterwards, I will show you how we can actually update this number here. But for now, let's try this out. And actually, let's comment this code out so that it doesn't get in our way. So command / for that. And let's go. And indeed, we see that the string was printed 10 times. That's what this 10 here stands for. So the DevTools will not print the same string 10 times. It will simply put this 10 here. But what matters is that this logic here actually worked. So now let's actually use this counter variable that we created here to actually increase the number in the string that we're printing out. So how do you think we will do that? Well, it's actually simple. All we have to do is to replace this number here with the current value of the counter, because this variable that we defined here, so this rep variable, it's just a normal variable, and it's going to be available here inside of this code block. So let's transform this to a template string so that we can then insert that variable into the string. So we get rid of the hard-coded value, and now we basically dynamically build the string. And so here, all we need to do is to put the rep variable. And now we get exactly what we wrote here manually in the beginning, right? So that works. And so let's recap exactly what we did here. So we wanted to log our string here, so a string like this, 10 times. But of course, it could be any other repetitive operation. Again, we're just using console.log here so that we can see the result in the developer console. Anyway, in order to solve this problem of not having to repeat the same code over and over again, we used a for loop. And so we initialized the counter of the loop at 1. So right here, we created this new rep variable, and rep again stands for repetition, but it could be any other variable name, of course. And so we started at 1 because, well, we wanted to start at repetition number 1. But we could also start, of course, at repetition 5. So let's see how that looks like. And then, as you might have expected, the first repetition that's printed is the number 5. Okay, but let's put it back to 1 now. So after each iteration of the loop, we then increase this counter value by exactly 1. And this happens by the end of the iteration. So in the first iteration, this string here is logged to the console with the current repetition, which stands at 1. So this here will be replaced by a 1, and then afterwards the rep counter will be updated to 2. Then in the next iteration, this same string here is printed, but now with rep at number 2. Then rep is updated from 2 to 3, and so on and so forth. And these loops keep running while the rep variable is less or equal 10. So basically, while this condition here is true. And that's how we achieve exactly 10 repetitions. So what the loop does is to verify before each repetition if our condition here still holds true. And only if it does, it will keep running the loop. So it will execute the next iteration, and so it will execute this block of code here one more time. And of course, we could change it to something else. Let's put it at 30, and then we should get, indeed, 30 repetitions of the same string where only this counter here is changed. All right, and in a nutshell, that's how the for loop works in JavaScript. In the next few videos, we will see some more useful applications of the for loop and also talk about another type of loop that we have in JavaScript. Let's now explore some more features of the for loop and also create a somewhat more useful example. And one of the most used applications of for loops is to loop through arrays. So let's get back the array that we were using before. So where is that? So I mean the one where we talked about objects. Yeah, this one. So go to this lecture about Introduction to Objects and then grab this Jonas array. And maybe you didn't write it back then, but then you can just write it right now. Okay, and so now we can use a for loop to loop through this array. And let's say for now that we wanted to individually log every element of the array to the console. So very simple. All we want to do is to log these 5 elements here. So let's write a for loop. And as always, we start with the counter. So let, and now a traditional counter variable name has been I for a long time. And so let's use that here as well. So just I, and this time we need to start it at 0. And that's because the array is 0 based when it comes to reading elements out of the array. Remember? And this will make sense once we actually write the code of this loop. Let's now actually skip the condition for now. So we're going to deal with that a little bit later. And so now updating the counter is going to work exactly the same as before. So since we want to log all of the elements, we need to update the counter variable simply by 1. And so again, we use ++. Okay, and now let's write our loop here itself. So console.log. And remember, all we want to log to the console is each element of the array. And so without the loop, we would write that like this. So Jonas 0, right? And then let's do that outside. So we would do this, this, and then all the way to number 4, right? So let's comment this out, but this is helpful to see what kind of code we want to achieve. So again, we want to start at Jonas 0, which is the first element. Jonas 1 is this one, then 2, 3, and 4. And so that's the reason why we started the counter at 0, because that's the first element that we want to get. It's Jonas 0. And so here, instead of hard coding the 0, of course, we are going to use our counter variable. So, and that's I. And now the trickiest part here is the condition. And so that's why we left it for the end. But now we need to actually tackle it. So for how long do we want to keep this loop running? Well, it should run when I is 0, right? It should also run when it's 1, 2, 3, and 4, because 4 is the last element. But when it's 5, it should no longer run, right? And that's because Jonas at 5 does not exist. Let's just write that. Does not exist. And so that means that the I counter variable should always stay below 5. So let's write that here. So I should stay below 5. And so with this, as soon as the counter variable is updated to 5, then the next iteration of the loop will not run anymore. So let's try this. And here it's of course not Jonas, it's Jonas array. So let's actually change the name up here in the array itself. Try that again. And yeah, we get a log of each of the elements in the array. So all of the 5 of them. Great. But there's actually still one problem with this, which is that we hard-coded the length of the array here with 5. So let's now say that we add another element. Let's say just true. And so if we try this now, do you think that true will be logged here as well? Well, it will not, because of course we are still telling JavaScript that I should stay below 5. And so it will not print the array at position number 5, which does now exist. So now we do have Jonas at position 5, right? And so the solution to this is to not hard code the value here, but to compute this value. So basically to get it from JavaScript itself. And how can we get this number? Well, actually this 5 is simply the length of the array, right? Not of this one anymore, but of the original one. So this array has a length of 5. And so 5 is exactly the number that we put here. And so we can simply replace the hard-coded value with a dynamically calculated one. And that's Jonas.length. Remember? So let's try that. And indeed, it still works. And if I now go back to adding something else, like true, then Jonas.length will now be 6. And that of course happens automatically, and we don't have to manually change any code in that loop. So now indeed true also appears here in our log. Great. Let's now also log something else here. Let's say the type of the variable. So type of Jonas I. And I hope that this part here makes sense. So the fact that we're using the counter variable here to retrieve all the elements of the array. So now let's say, so string, string, number, string, object. So remember how I said that an array is in fact an object, and here we have the proof of that. And then finally the last one is of course a Boolean. Okay, so I hope that this logic here made sense. And so this is, in a nutshell, how we loop arrays using the for loop. Now, what we did here was only to read values from an array. But now let's also at the same time create a new array which will contain this type of each of the elements. So basically this. All right. So again, what I want to do now is to create a new array which will contain all the types for all these elements. And if that sounds a little bit useless, then just keep in mind that these are all just educational exercises. So I designed them to show you how these different features of the language work. So in the real world, we would probably not create an array with types of variables. But this is excellent to show you how to create a new array based on the values of one original array. So to do that, we start by creating a new empty array outside of the loop. And let's do that here after this one. So I will call this one types. And now I think this is something we didn't do before, which is to simply create an empty array. And all we have to do is to basically create an array with the usual syntax, but without any element inside of it. And so now we have to go here to the same loop, because this new array types will be based on the Jonas array. So it's going to have the same length. And so we can use the exact same loop that we used to read data from the Jonas loop also to construct this new types array. So let's say types at position I should be equal to type of Jonas at position I. And remember that this works because we can essentially do this. So we could do it again without the loop and say types 0 is equals string. So this would work, right? And so of course it also works with the index number here dynamically. And so that's exactly what we're doing here in the exact same way as we read data from the Jonas array. Right? So in iteration 0, we will have type 0 equals type of Jonas 0. Then in the next iteration, we will have types 1 equals type of Jonas 1, and then 2, 3, 4, and 5. All right. So just to see if that works, let's then log to the console this newly created, or to be more accurate, this newly filled array. So let's see. And indeed, now we get this array, which has exactly the types that we can see here as well. So string, string number, string, object, and Boolean. So these 6 that we also have here, which means that we achieved our goal here. Now, this is just one way of filling an array. And let me write that down here. Filling the types array. And here we do basically reading from Jonas array. But this is just one way of doing it. So let's comment out this one and do it in another way. And do you remember how to add elements to an array in another way? Well, we could use the push method, right? So that would be types dot push. And remember that push adds a new element to the end of the array. And so here we now need to pass in the element that we do want to add on to the array. And so that's again type of Jonas at position I. So of the current counter. And so if we try this now again, we should get the same. And it's important that we add the new element to the end of the array and not to the beginning. So we really need to use push here and not unshift. So I think that this way of doing it here is actually a little bit cleaner. But if you prefer this first way here, then of course you can just use that one as well. But what matters here is that we really understood the logic of how to construct all the different parts of this for loop in order to loop the array. So it starts with the counter being 0 because that's the first element of the array. And then this condition here, which specifies that the current index always needs to stay below the length of the array that we're looping through. And then in the loop itself, we always get the current element using the current counter, which is going to go from 0 to the length of the array minus 1, basically. All right. And to make sure we really get this, let's try another, maybe more practical example. So let's go back to having an array of birth years. So 1991, 2007, let's say, 1969, and 2020. And now what we want to do is to calculate the ages for all these 4 birth years here. And we want to store them in a new array. And that's a very common type of operation, which we actually already did before, but without using loops. So essentially that's what we did in the tip calculator challenge. Here. So here we had an array of 3 builds, and then we manually calculated the tip for each of them. So manually we specified the index 0, 1, and 2, and created a new array based on these values. But in the real world, we would have used a loop to do that. And so that's what we will do now. Okay, just with another a bit more simple example. Years is the array which contains the birth years. And now let's create another, and again, empty array, which will then hold the ages. And so what we're going to do now is to loop through years and then fill up these ages array. So 4. And then once more, let's define the counter at 0 for the same reasons that we did it before. And it's not a problem that this counter variable here has exactly the same name. Then the condition is also going to be the same. And actually the whole loop always kind of looks the same when we loop over an array. So now here the difference is that it's of course years.length. And then at the end we, as always, increase the counter by 1. And now what we need to do is to calculate the age of the current year. So that's going to be 2037. So as always, that's the year that we're currently in, let's say, and then minus the current birth year. So how do we get that? We say years at the current loop position. Okay, so that's nothing new, I hope, now at this point. Okay, so we have this calculation now, and now we want to add it to this new empty array. So we say we want to push it to that array. And so we use the push method to do that. So ages dot push. And so this is the value that we want to push into this empty array. And that's actually it. So let's check it out in the console. And here we go. So just to confirm, 2037 minus 1991 is of course 46. And let's just do it with 27 as well, 2007, I mean. And so that's 30, which is this one. And so this array result is correct indeed. So what we essentially did is this. We cannot do operations between simple values and an array. So that I showed you earlier, right? We cannot do 2037 minus the years array. That will just give us not a number. And so here in this loop, we basically did it individually. So we did the calculation one by one. In each iteration of the loop, we calculated 2037 minus this year and then added it to the first position in the ages array. Then we did 2037 minus this and put it at the end of the ages array again. And then the same for this one and for 2020. Great. So that is a very, very useful and important application of the for loop. And now to finish, let's learn about two important statements for loops. And that's the continue and the break statement. Let me just write that here. Continue and break. And let's start with continue. So continue is to exit the current iteration of the loop and continue to the next one. On the other hand, break is used to completely terminate the whole loop. So let's see two quick examples for that. And let's go back to actually this first loop that we had here, where we looped this Jonas array. So I will just copy this because we already learned how to loop through the array. And now I'm just interested in showing you how continue and break work. So let me delete this and this as well. And now let's say that for some reason, we only wanted to print elements to the array that are strings. And the continue statement is perfect for this. Because again, with continue, we can exit the current iteration of the loop. So what we can do here is to say, if the type of the current element, so of Jonas I, is not a string, then continue. And so that's how we write the continue statement. It's really just this continue keyword. So again, what we want to do here is to only log strings to the console, which means that everything else should basically be skipped. And that's what we do here. So we say if the type of the current element, so that's this one here, so if the type of the current element is not a string, then continue, which again means that the current iteration of the loop is exited and then the next one starts immediately. So let's just write some other note here to the console just so we know what we're doing here, like only strings, because otherwise the output here is going to start to look a little bit confusing. But anyway, let's test this now. And indeed, we only get strings now. So these three are strings and all the other ones are not strings. So this number, this array, and this boolean, so they will now not get printed because we basically skipped them. For example, that age number, which is 46 here, so the third element, does have the type number here, right? So it's not a string, and so this here will be true because, of course, number is different than string. And so this is true, and so this code here will run. And what continue will do is that it will immediately exit the current iteration. And so this line of code here will not be executed in the current iteration. It will not even be reached. Okay? And now finally, let me just show you how break works. And remember that what break does is to completely terminate the whole loop. So not just the current iteration. So what we want to do now is to log no other elements after we found a number. So essentially, after a number is found, which will be this 46 here, nothing else should be printed. So let's do that. And I will again copy all of this. And so let's say here, break with number. So let's translate the logic that we just said into the code. So as soon as a number is found, we want to break the loop. So our if condition here should be type of Jonas I, so the current element, if it's equal to a number, so now that's number, then break. Now, okay, let's see the result here. And indeed, that's exactly what we wanted. So after the first number is found, which is this 46 here, nothing else is printed. So in this iteration, where the number is found, not even this line of code is printed anymore, and then the loop is terminated completely. All right. Now, this might not sound very practical, but believe me, there are some important use cases for continue and break. It's just hard to create some small and isolated code examples to show you just how useful they can be. But anyway, I wanted to let you know that continue and break exist. But the most important takeaway from this lecture is definitely to understand how we can loop through arrays using this kind of logic here. Okay, so this one here is really important that you understand this snippet of code.